NPN transistor sensing circuit. Recall from earlier lesson on NPN transistor, the NPN transistor functions as a switch and a small current is required through the base to turn the switch on. The basic components required for this sensing circuit are the switch, the light bulb, NPN transistor with the 3 pins, emitter, base, and the collector as shown. And last but not least, the resistor connected to the base of the transistor known as the base resistor. It is used to limit the maximum current that flows through the base of the transistor. You will be introduced to 3 sensing circuits. First, the temperature sensing circuit. Connect the potentiometer to R2 port. Then connect the thermistor, which is used to sense the change in temperature, to the R1 port. I will increase the temperature by rubbing my fingers together and hold the thermistor. You will observe the bulb starting to light up. When I remove my finger, the temperature drops and the bulb gets dimmer. The circuit is connected such that the higher the temperature, the lower the resistance, resulting to a brighter bulb. Let me show you how the current flows. First, a small current flows through the base and activate the transistor, allowing larger current to flow through the collector, emitter, and into the light bulb, causing it to light up. Next, let's move on to examine a moisture sensing circuit. The extra item required for this circuit is some tap water and 2 wires. Replace the thermistor with the 2 wires at R1 port. Everything else remains unchanged. Remember to on the switch and test that the circuit is properly connected. As shown, when the open ends of the wire touches, the circuit is closed, as indicated by the lighted bulb. Place both wires inside the water without the wires touching. The bulb lights up. This shows that when there is moisture, in this case water, the circuit is closed. Note that water is a poor electrical conductor. Let's look at how this circuit works. When there is moisture, the circuit is closed, allowing a small current to flow through the base and activating the transistor, allowing larger current to flow through it into the bulb and light it up. Lastly, let's look at light sensing circuit. Everything remains the same as the temperature sensing circuit, but this time round, replace the thermistor with LDR, light dependent resistor, at port R1. Turn on the switch and observe the bulb light up. Blocking some of the light by putting a pen just above the LDR, you will observe the bulb gets dimmer. Now, block the light entirely by touching the light sensing surface of the LDR. Notice that the bulb doesn't light up anymore. This is how it works. When the switch is on, a small current flows into the base, activating the transistor, allowing larger current to flow through it into the bulb and lighting it up. The more the light received by LDR, the higher the resistance. In comparison, the base has lower resistance. Since current chooses path with least resistance, current flows into the base. However, when the LDR is entirely covered by the finger as shown, it senses no light. This results to a low resistance at LDR. Since current chooses path with least resistance, insufficient current flows into the base. Therefore, transistor cannot be activated. This function of the circuit can be reversed by swapping the components at R1 and R2 port. Turn on the switch. Notice that the LDR is currently at R2 port. Observe that the bulb did not light up. Now, block all the light by touching the light sensing surface of LDR. You will observe the bulb lights up. And this is how it works. When the switch is on, the bulb did not light up. This is because in this case, the function of the LDR is reversed. When the LDR sends light, the resistance is low. In comparison, the base has higher resistance. Since insufficient current flows into the base, it cannot activate the transistor. However, when the light is blocked by the finger, resistance at LDR increases. The base now has a lower resistance compared to LDR, thus sufficient current flows into the base, activating the transistor and lighting the bulb. We have come to the end of circuit building lessons. Thank you. Hope you have a better understanding for NPN transistor and 555 IC circuits.